Hello, welcome to this channel Vidyarthi with Concept. My name is Shubham Raj, and here in this class we will learn about kinematics. So what is kinematics? Actually it is a part of mechanics. Mechanics is divided into two parts. One is kinematics and other is dynamics. In kinematics we describe motion in equations and graph without knowing the cause behind it. Okay, but in dynamics we learn about motions and describe their phenomena through graph or mathematical expression. Okay, and in dynamics we generally talk about the reason, the cause why something is moving. Okay, but in kinematics we learn only um, their motion. We learn to describe mathematically or graphically about their motion without knowing the reason, cause behind it. Okay, so describing motion with equations and graph. Okay, so let's take an example here. Let's take first example. So there is a table I have, and on this table there is a ball. Okay, this ball is placed at some distance from this point. So if you have to measure the position of this ball, uh, we have to take some other things as reference. Okay, without taking reference we can't measure the position, we can't locate the position, we can't express the position of any body. Okay, so either this point or any other things surrounding this ball, take them as reference point. So let's take this point as a reference point. So position of this ball from this point, for example it is 40 centimeter. Okay, so now this is the situation, this is the uh, position, this is the situation of this ball. Okay, now how we will plot this situation, how we will graphically show this situation. Okay, so in your notebook you will have a graph. Through graph we can plot this, we can show this situation. So this is our x axis and this is our y axis. These x and y are position. This x is the position, shows position in this direction, left right, and this y axis shows the position in this direction, vertically upward and downward. In this situation we took the position of this ball from the reference point, and the reference point can many possible ways. Okay, but in this graph, in this coordinate axis, we will take this origin as a reference point. And from this origin we can show the position of any ball, any things, any body. Okay, so this ball is at 40 centimeter from the origin, so we will say 1 2 3 4 so on 40 centimeter. So your ball is at this position. So this is the position of my ball from 0 to 40 centimeter. Okay, so here is my ball. Okay, Now, how can we express this situation mathematically? Let's see. So, the position of this ball is 40 centimeter. So, we will write position is a physical quantity. So, we will write x is equal to 40 centimeter. So, you can say that this is your equation of motion. Since it is not moving, it is not changing its position with time. After 2 or 3 seconds, again when we see this ball, it will not change their position. Okay, it will not change its position. So this position of this ball doesn't depend upon time. Okay, so here you can see that in this equation of motion, that position is a 40 centimeter. Okay, after 2 or 3 seconds the position will not change. If it has to change, then there must be some t terms here. Okay, so this position doesn't depend upon time. This is your position. Okay, so now this is your xy axis. Okay, position in this direction, position in this direction. So your ball is at this point. Okay, we can also draw other coordinate axis, other uh, graph where position and time axis are plotted. Okay, so here take another graph. If we will assign this x axis with t, with time, okay, and this y axis with position. Okay, this time in second and this position in meter. Now at t is equal to 0, at the starting of our observation, when we start to observe this ball, when we started to examine the situation of this ball, at that starting point of time our time was 0. Okay, so at t is equal to 0, the position of the ball was 40 centimeter. So 1 2 3 4 5, let it be here 40 centimeter. After 2 or 3 seconds or 2 or 3 hours, whenever we see this ball, we get only we get same position. Okay, at this second, at this time the position is here, at this time the position is 40 again, at this time the position is 40. So we now join all this location, all this point. Okay, these are point. The value of this point is for example 1 2 3 4 5. If it is 5, if it is 5 second, then here 5 and position is 40, here 4 and the position is 40. So first x axis, then y axis, these basic things about graph. So this is a graph between position and time. Okay, if you have to plot a graph of this ball, of this motion between position and time axis, then you can plot that type of graph. And if you have to plot xy axis, where xy axis is used to locate the position of the ball, so you will have to do that I did earlier. Okay, so that's it for today.